Hello everyone. Welcome to today's meetup. We're very excited to have all of you join us here today. We are here. So my name is Dalia and I'm from Elastic's community team. Today we're here to hear from James. He will introduce himself. He will talk to us about sizing the Elastic Stack for security cases. Let's try to take all of the questions at the end, so then James has more time to answer them. And yes, enjoy the meetup. James, please take it from here.
Thank you, Dalia. Hi, everyone. Good morning, afternoon, wherever you're from. As always, we have to cover all time zones. Happy St. Patrick's Day as well for those of you who do celebrate it. I don't drink, so I don't celebrate it. It's not why we have it today, but anyway, I just thought I'd bring it up there. We're just going to leave some time for everyone to join, so we'll probably start in about 1 or 2 minutes. But thank you all for joining yet another virtual event. I know there's so many of these going on at the moment that it can get really tiring, so we do appreciate you taking the time to do this. It's also the first time I'm using this platform and streaming live, so if we screw it up, I'm very sorry, but hopefully everything works out okay. And yeah, then of course it will be recorded, so if you did want to share it or rewatch it or do whatever you want, that's fine. As we're going through this, there's going to be quite a few examples of quite a bit to cover, and as Dalia said, feel free to ask any questions that you have and we'll try and get to them all at the end. All right, I think it's good to go ahead and start. So again, my name is James. I'm on the product marketing team at Elastic, focusing on security. If you were on the Slack workspace, the community Slack workspace, you'll see me there all the time. James Spiteri, I'm on all the channels. And the reason we're doing this today is actually a conversation that came from there. So we have a lot of questions about, hey, listen, I'm using Elastic for security analytics, whether that's personally, that's part of managed services offering or anything like that. And we need some tips and tricks about what we can do to make sure we're sizing our clusters appropriately. The Elastic Stack, there's many moving parts, there's many components. So there's, you might find yourself struggling with making sure you have the right sizing and the right configuration. And I thought, hey, you know what, let's have a meetup. Let's talk about some things. Let's give some tips and tricks and take any questions as well. Obviously, there's a ton of content that we have in terms of blog posts and Elasticon recordings talking about sizing, but sometimes it's just good to hear it and see some examples, especially for security. All right, so what I'm going to talk about today, very quickly, the agenda, more or less. I will change things up a bit. I just like listing things out just for my sake. But here's what we're typically going to cover. So we're going to talk a bit in detail about the Elasticsearch internals. I know as security analysts, we don't typically always care about everything that happens within Elastic, but to size appropriately, sometimes it's good to cover that detail. So I'll be going in a bit of detail about how Elasticsearch works, what happens when a log gets ingested, what happens when you search a log. So we're going to cover some of those as well. Then we're going to talk about preparation. So what do I need to do to make sure that when I go live with my Elastic cluster, I have prepared myself, I know how much data I'm going to ingest, more or less, obviously, and we can size out the cluster accordingly. We're going to talk about performance. So what can we do to make sure we have the appropriate hardware, that we're using the right hardware profiles, whether that's bare metal machines, cloud machines, so on and so forth. We're going to see how we can effectively balance out speed versus cost, because there is always going to be a trade-off. You either want something that's going to be really fast, or you're going to balance it out between speed and hardware costs. We're going to talk quite a bit about cross-cluster search, because I think it's one of the core features to make our lives easier when sizing big security deployments. And we're actually going to, I've built a demo of it working live, so you get to see what that looks like if you've never had the opportunity to try out cross-cluster search. We're also going to talk about data tiers, so the concept of having hot, warm, cold, etc., etc. I'm going to be covering something called transforms, which is a feature within the Elastic Stack, which is highly beneficial for huge data workloads. And again, I have a bit of a demo running on there. And then there's 2 more things we'll cover. One is Kibana. So because as security analytics, we're doing a lot of detections. We ship with over 400 detections out of the box these days. It's important that we make sure that our Kibana nodes, or instances, I should say, can handle that detection load, because Kibana actually does the scheduling of those detections. So we'll talk a bit about that. And then we're going to give some example scenarios for sizing. These are mainly they exist on our website already, but I'm just going to talk about them again. Let's go ahead and dive right in. So obviously we're going to be talking about elastic security here, but this is very similar for any heavy logging use case. The only reason that we're talking about security today is because we're going to be talking about things like, again, the detection engine and those scenarios as well. But in reality, if you're using the Elastic Stack for anything other than security, in terms of heavy logging workloads, most of these are going to apply as well. So don't feel as though this is hard and fast just for security. But security in general, it came up because this was the topic that was asked. So that's why we're going to be focused on security today. And for those of you who aren't too familiar, so maybe you're joining this, if you're joining this, you probably use Elastic and you want to know more. But when we say Elastic security, we're talking about the security analytics or SIM side of the story, as well as the data coming from Elastic endpoint. So that's what encompasses Elastic security. All right, so very briefly, there are a couple of computing resources that we should talk about when we're discussing the Elastic Stack, or most stacks in general, but Elastic specifically in this case. So let's see what we mean. So there's four main things to consider always, right? So you have storage. Hey, where does my data live? Where are my security logs stored? Memory, when I'm searching, where's my data buffered? Compute, where is it processed? And network, where is it transferred? Since Elastic is a cluster technology, you're meant to be running several nodes, network is important to talk about. Even when we talk about things like cross-cluster search and cross-cluster replication and stuff like that, network is a component. We have seen situations where there's high data transfer between nodes, for example, and network links get saturated. Sometimes a gigabit interface isn't enough. Sometimes you need to bump it up. So it's important to keep that in mind. And you see at the bottom of each of these, it talks about, it gives an example. Storage is like words in a book. Memory is like words you read, analyzing words, and then speaking those words. So it's a good analogy to try and remember how these concepts fit inside of like a search or security analytics lingo. So with that in mind, how does it fit into the Elasticsearch internals? What happens when I send data to Elasticsearch? And then later we'll see what happens when I search data in an Elasticsearch cluster. There's also a lot of terminology we use. And so someone coming fresh into this might not know what an index is, or what a shard is, or what a Lucene segment is. We won't go into too much detail, but it's important to cover them slightly in slight detail. So a cluster essentially is a group of nodes. So Elasticsearch is a horizontally scalable technology. So you should never run a single node of Elasticsearch unless you're testing or you're trying something out. A cluster is a group of nodes, and Elasticsearch is a cluster technology. What is a node? A node is essentially a host or machine that runs Elasticsearch software. And Elasticsearch is based on Java, so it lives in the JVM. So essentially, a node is a Java process that runs Elasticsearch. An index is housing your data. It's typically a group of what we call shards, and we're going to talk about shards in them. But an index is essentially where the data ends up living, the logical data store, as we like to call it. And then we go a layer below that, which is the shard. So Elasticsearch is based on Apache Lucene, and a shard is part of a Lucene index that stores a portion of your data. Because Elasticsearch, again, is a distributed search engine, we're going to see how when you have an index, if you want to get the most out of your distributed search performance, you're going to have multiple shards that live on different nodes to get the most out of your distributed search. Then we have segments, again, which is Lucene, essentially, like the core Lucene. And then we have documents, which is the log. Security world, this is where your events end up as documents inside of Elasticsearch. So whenever we say a document, in reality, we mean a log. So your security events, your Windows event log, your firewall logs, these all end up as documents inside of Elasticsearch. So don't get confused if someone tells you, how many documents do you have in your cluster? What the heck is a document? A document essentially is a stored log in JSON format. Cool. All right. So this is sort of a bird's eye view of an Elastic cluster. So you see we have the stack there. So we have Kibana, Elasticsearch, Beats, Logstash. If we dive deep into Elasticsearch, there's many different what we call node types. So if you remember, we live, so I should say Elasticsearch is made of a cluster of different nodes, and different nodes can have different node types. The bigger your cluster gets, the more of these node types you're going to have. Or I should say different node types you're going to have. And you can see here, this image is essentially your average Elasticsearch cluster. So you have a couple of coordinator nodes, ingest nodes, data nodes, master nodes, and then even if you were running something like machine learning, you can have dedicated machine learning nodes. And then you can see here where it bubbled up those data nodes. This is how essentially your data sits. So you have a path on your operating system where Elasticsearch is installed, and that's where the leucine segments and the shards end up living. So sometimes it's important to get into this detail because it's going to help you understand why there are so many components to take into consideration when sizing Elasticsearch. But this is a really good high-level overview and a sort of a bird's eye view of what a cluster looks like. Now, different node types. So different node types are doing different things. This is a really, really nice way of looking at it because we take into consideration those resources we spoke about in the beginning. And each node type uses different types of resources. That's why it's important to have appropriate hardware profiles for these nodes because they all do different things and they all have different resource requirements. So for example, on data nodes, where you're going to be retrieving and searching and indexing and storing, you can see those are, they need a lot of resources. So storage needs to be super fast, especially for your hot data. They're going to be high memory, high compute, and your network is, depending on how big your cluster is and how much data you have, it's something to consider as well. And then if you look at things like master nodes, where they're essentially handling what we call the cluster state, which is which nodes house which data, so on and so forth, they're relatively low, right? So compared to what you're doing with data and searching it, they're relatively low compared to the rest. We won't get into all types, but obviously these slides are going to be available to you, and I think this is a really nice, quick reference. Node types that we use to run our SaaS servers, Elastic Cloud. And that gives you an idea as well of how we architect those different node types. So we'll make sure to send over that link as well. But these are sort of the important things to consider. And that's why we have these different node types as well. And this is a really nice overview of what happens when data hits an Elastic cluster. So when you're ingesting data. And again, this is why it's important to understand why it can be a bit complex to size sometimes. Not always, but there are certain situations where you have to take a lot of things into consideration, especially as your data grows. In security world, this could be a Beat, Elastic Agent, Logstash, anything that is going to feed your security events into Elasticsearch. Okay, and typically it's that put there refers to the backend API call that it makes. So it makes what we call a put request. It's going to add data to Elasticsearch. Now you can see the first thing in this diagram is a coordinator node. What's a coordinator node, right? So a coordinator, it's like a router. So when your data hits your coordinator node, it is going to decide the best nodes in the cluster to put it on, based on the load, based on the performance, based on where data sits. The coordinator is going to handle that first layer of say, okay, this agent that's sending me Windows event logs, I've received it. Which is the best node for me to put this data on? And you can see there's a step before that, which is the ingest node. So as we know, or hopefully most of you know, that there is a node type in Elasticsearch which can do data processing, so data parsing, and a couple of other things. It can even do like an enrichment based off of another index. And you can have a dedicated node type for that to make sure that your data nodes don't get affected. So if you want to do any parsing, any heavy parsing on the Elasticsearch side, we always recommend ingest nodes. And you can see if you have data which is going to get parsed first, it hits the ingest node. and then it gets sent to the data node. So it's a very important step if you're going to be doing a lot of heavy parsing, especially with security events. There's a lot of parsing involved. It's very important to have ingest nodes. If you have Logstash in your architecture, you can probably get away with it without having ingest nodes. So most people will either do parsing on the Logstash side or they'll do parsing on the ingest node side. That's going to be up to you. There are advantages and disadvantages to both. I have started to recommend ingest pipelines more and more just because they're part of the cluster and it's easier to scale. But you can see here that is the next step when you're adding data. Then it gets added to the data node. If you're replicating data, which most people do, at least one replica, it gets replicated. And then you can see what happens in the Lucene world, where it gets analyzed if it's text. If not, it gets written to the segments, and then it gets written to disk. So that's how it all works out end to end. This happens in milliseconds most of the time, but it's really important to understand where these complexities come from. That's where there's a few moving parts which we have to take into consideration when working with data at scale. And you can see at the bottom again where those compute resources fit in, the network, the storage, in each part and each layer. This is a really nicely laid out diagram. I can't take credit for this diagram. My colleague Dave Moore put this together, but I just thought it was perfect for describing where some of the complexities come from. So with that being said, the first step to make sure that we're going to have a successful deployment and a successful cluster. When I say successful, it means my security analysts sat down, they asked a question, they ran a query, and they got results in a good amount of time. That is what I mean by a successful deployment, and that it stays up and running and stable, and we don't get calls in the middle of the night because the cluster is down. The most important part is preparation. And when I say preparation, I mean understanding how much data am I sending, how big is it, and how often is it being sent. So that is key here. You cannot go into production mode without doing proper preparation. And as I like to say, proper planning and preparation prevents poor performance, the 6 Ps. This is very true for Elasticsearch and the Elastic Stack in general. How can we prepare? So there's a couple of things I'd like to share with you, some things that have been really successful for me. And the best way to prepare is ingest a sample of data. Now, why do we do that? Because when you're ingesting data, you can monitor it. You can see how it's growing. You can see what the size is on disk. You can see how it grows over time. You can see how heavy it is on Elasticsearch in terms of the Java performance as well. And we're going to see that. I'd also like to share with you an Elasticsearch plugin called Mapper Size. And you can see this screenshot is actually based off of data from Mapper Size. What Mapper Size basically means is it's going to see how big the source data that you're sending is on disk. And that will give you a really good indication of how much storage you're going to need. So I'll be showing you what that looks like in a second. And at the bottom, there's a graph of the monitoring. We're going to get deep into that. But it's also important to monitor things like your ingestion rates as well. So let's look at a bit of this and what I mean. So why should we monitor? I know there's a question about DDoS and how we can help with that. I will answer you in a second. I'm going to answer all the questions in the end. So let's look at monitoring. So I have my cluster here. It's a relatively medium-sized cluster. It's 24 nodes, a ton of different data types, about 10 terabytes of data. Why is it important to monitor? So if I click on the indices page, so by the way, monitoring is by default in every cluster, right? So you don't have to do anything. It's not a licensed feature. It's available to everyone. And what this gives you is really deep statistics about how your data is growing and how it's how it's impacting your cluster. So here I have my different indices. You can see I have quite a few. I have 871 indices, and I have about close to 12 billion documents, 10 terabytes of data, 1,900 shards. What's nice about this is not only does it give you sort of the index sizes and stuff, but it's telling you how much you're indexing, right? So right now I'm seeing, if we go to the overview, we can get sort of an overview rate. I'm doing about, more or less 1,000 events per second of ingest, with replicas that doubles obviously to about 2000. So I know just by this data that I'm sending, I'm already hitting 1000 DPS, right? So that's the first sort of monitoring metric that I can see. But I can also see what's important is the indexing latency. So I'm sending right now 1000 events per second, but my latency is almost negligible, right? So 0.2 milliseconds, which is good. That's a good sign. So my indexing isn't struggling. I can see that I don't have any, or my indexing latency is almost completely negligible. I can see my search rates. I can see my search latency as well. So about 100 milliseconds more or less, which is quite good. But what I like to point out is if we go back to indices, this is where the planning comes in. So if I'm sending this data here, I can see how it's growing over time. So if I do the last 24 hours, I'll be able to see how much data I've been consuming over time. So if you see this chart is steadily growing up, so then I can say, I can build an average and say, okay, my data is growing at a rate of about X gigabytes per day, 10 gigabytes per day, 100 gigabytes per day, whatever it may be. But all of this is collected. And this is a really good way to make sure you're doing proper planning for your data. Now, obviously, in production, you have to cater for that. So if you're sending a sample size of, let's say, okay, I'm sending about 10% of the traffic I expect to get, then you have to work out and basically calculate, okay, this is how much I need overall. But this is giving you a really good starting point to make sure you're going to take that into consideration. And this is true, again, for every single index, right? So really, really important. Not only the indexing and the index rate, but you can also see in terms of the monitoring, everything from, if you're using something like Logstash or Beats, you can see how your pipelines are performing as well. And this is also really important. So for example, here I have a pipeline and I have a lot of operations. Well, a handful of operations here. I've seen Logstash pipelines with, thousands of filters, but you can see how long the data is living inside each filter. So as you're bringing data in, you can see, okay, here is where I have my bottleneck. Right now, the most I'm waiting in my filters is 0.02 milliseconds per event, which I think that's okay, right? Granted, I'm only doing about 209 events per second in this pipeline, but I can see that there are no bottlenecks. And to write data to Elasticsearch, it takes about 2.3 milliseconds per event. These are key metrics to make sure that, one, my Logstash can handle the load, but secondly, my Elasticsearch cluster can handle the load. If this was very high, there might be a problem with my indexing rate. So that is something I would want to go and look at. So all of these are going to give you really good statistics when planning your production level cluster. Really important to turn this on. Do not miss this step. It is really important. If we look at something like the mapper size data, so here I have, what is mapper size? So again, it is an Elasticsearch plugin. Not many people know about this, unfortunately, but it's really, really useful. So what this does is it calculates the size of the original source message. So what the beats would have sent, what your firewall would have sent, whatever it may be. And it calculates it actually before it gets compressed. So it gives you an indication of how big that data is, like the average source size you can see here. And I add this, you basically add it to an index template, and then it computes it every document. And you can see then I work out the average. So, okay, I am sending here data from AuditBeat, and I can see, for example, my user events, the average size for that is about 1.8 kilobytes per event. Okay. And then I can see in the last 24 hours, I've had just about 1,000 user events. 1,000 times 1.8 would give me a number, which is what I need to then work out how big my cluster should be eventually. Obviously, there's more statistics you can do. You can look at, if you're going to be sampling data for a couple of days, a week, you can build graphs of all of this. It's just Kibana at the end of the day. But really important to make sure that you have the right size in there. We, as Elastic, we can give you estimates of what we've seen and what we think. But at the end of the day, everyone's data is slightly different. So the only real way to know that you're setting yourself up for success is taking these steps. It's really important. I cannot stress this enough. Every time, I've worked with customers and the users, big and small, 5 node clusters, 1,000 node clusters. I always tell them the same thing. you have to take these steps, because I can give you advice and what I think the data is going to be like. If you don't do stuff like this, you're going to have a bad time, because this is a necessary step. So that's mapper size. You can also get these statistics for ingest node pipelines, by the way. So if you are using ingest nodes, not Logstash, let me zoom in a bit here. Unfortunately, this is an API call right now. We don't have a UI for it yet. But you can see here I can get ingest node stats, how my event is, my time in milliseconds per event, any processors, how long that takes. So we also collect this information. Again, unfortunately, we don't have a UI for it, but at least it is collected and you can reference it when you are building your deployments. And this is the API call. And you can see I filtered for ingest nodes in particular. All right, so that's from the preparation standpoint. Again, probably the most important step in all of this. If you don't prepare properly, you're going to have a bad time. All right, let's move on. So this is like basically a summary of what to take into consideration. So once we do that preparation, roughly we're going to have an indication of how many gigabytes per day, and then we're going to need to know how much we're going to retain it for, how many days it's going to live in the hot zone, warm zone, and how many replicas do you want. Right? Typically, one replica is enough, but we'll talk about a scenario where you might want more replicas, depending on your data resiliency strategy, how crucial that data is to you, what's your appetite for failure. So these are all things to take into consideration. And obviously, add a couple of % here and there as a margin of error, and to stay below, because Elasticsearch does have that watermark of disk full. So do keep that in mind. Performance. So how can we calculate that the node profile I've chosen is correct for the data I'm going to be sending? And there is one answer to this, and we have a benchmarking tool called Rally. If you've never used it or you've never heard of it, it's on our GitHub. So just Google Elasticsearch Rally. It's basically it's a Python package, and what Rally allows you to do is basically run a race. And what we mean by race is it's going to get a data set, and it's going to do a couple of operations on it on that node that you've chosen, or even an existing cluster. So let me show you. I'm going to actually run Rally right now. So let me load up here. I have a host with Rally. Just a second. Okay. So I ran one previously, but we'll run one together as well. So what Rally does is this. So you have a couple of what we call races available to you and tracks. Essentially, you're going to say, okay, on this node, I would like to test my performance on Elasticsearch version 7.11.2. I'm going to run HTTP logs. So we have a couple of different tracks. There's a couple of different challenges as well, so you can do different things. And then in the background, what it's actually going to do, unless you ask it not to, it's going to go ahead and download Elasticsearch, run it, and do all these different operations and give you things like throughput, indexing throughput, searching throughput, everything. So you can see here my minimum throughput was 807 documents per second for appending to an index, as an example. And this lets me calculate that, okay, based on what I'm seeing here, this node is going to allow me to index this much data or search through this much data in this amount of time. And Rally is key. If you're not sure if your disks are fast enough, if you have enough CPU, if you set the right JVM, Rally is going to give you that answer. Again, Rally can run on existing clusters. It's important that you run Rally on nodes which are going to be as close to production as possible. So don't run Rally on your laptop and get the results and then say, okay, on my laptop I got this, and then I'm going to replicate that in production. No, you have to run it on as close as the end-to-end environment as it's going to be in production. So very, very important. And again, I'll just run one together here. So I'll use the exact same command, but you can see what it will do in the background. It's going to basically go ahead. My settings are probably already cached here, but in the beginning, it would download the version of Elasticsearch I told it to, and then run through that track. For those of you who don't know, we do this every single day, and we publish these results. So these are what we call our nightly benchmarks. So these are all available for you to see, benchmarks.elastic.co. You can basically see everything that we run. We recently added a track for EQL data. So when we introduced EQL into Elasticsearch, which is our event query language, I actually helped with this. We set up a data set which is based off of endpoint security, just to see how performant EQL queries are, and we run that nightly as well. So you can see those performance metrics too. But you can see here how it basically runs everything in the background and basically gives me the results back. If you wanted to, you can actually have these results saved to an Elasticsearch cluster, so then you can run reporting on them as well. But Rally is the tool for making sure you've chosen the right hardware profile. Really, really important. If I just list out the tracks so you can see them, let's do that real quick. You can see the different tracks which are available. So there's EQL, and it will give you as well things like how much data it's going to process. So you can see this is pretty big. So uncompressed, this is going to go through 100 gigs of data, and then there are the different challenges. There's a bunch of different data sets here. All of this is really properly documented. We have a read the docs page for Rally, which goes into explicit detail, even things like creating your own tracks. So if you have like custom application logs that you're going to ingest for security, you can actually build your own track of that as well and then run it. So there's a ton of things you can do with Rally. Very important to make sure that you have the right hardware profiles. Super important. So that is key to measuring the performance of your hardware. And again, this is an example of, we make these stats all available. So if anyone wants to go see them, benchmarks.us, I think I have it here actually. Yeah, I do. So when you go to benchmarks.elastic.co to tell you what track you want to look at, I'll just zoom in a bit, and then you can see the performance. So basically this is saying, nightly EQL, two-stage sequences, size of 1,000, fetch of 1,000, roughly 4 milliseconds, so on and so forth. So you can see the performance there as well. So really, really nice. And all of these are provided. You can go ahead and see them every day if you want to. They're always there. All right. So let us carry on, just keeping track of time. So search speed, right? So how do we make sure that we have the optimal settings to make sure that our analysts, when they're doing threat hunting, when we're running detection rules, how do we make sure that we've set up our cluster to have a decent speed, right? So it's not just about just ingesting data. We need to make sure we get the data back in the right amount of time. And Elasticsearch was built for speed. So this is a similar diagram to what we saw for ingestion. This is what happens when you search. So as my client, whether that's Kibana or whether you're using something else, most users will use Kibana, which is their client there. You can see that it's going to ask the coordinator node in the same way. The coordinator node is going to reach out to the data nodes appropriately, and then it's going to retrieve the data from the segments as they live on disk. Now, if you remember what we said in the very beginning, Elasticsearch is distributed. So as a cluster, the power comes in from having that distributed search, which means essentially when you do a search, you can use compute from all the nodes in the cluster if you wanted to, if that's what you wanted to do. And it means it's gonna get significantly fast search back. Obviously, there is a trade-off there. So the more nodes you have, the more hardware cost it's going to have. So that there's going to be an implication there. And this is why, it's always about balance. How much are you willing to spend in terms of hardware costs to be able to have even faster search? Now, in the Elasticsearch world, typically, if your cluster is sized accordingly, you're going to get fast search anyway in terms of what we're used to, or if you're used to things like relational databases and stuff, we're still going to be talking seconds here. But in the search world and security world, it is a bit different. So we have users, if you go to Wikipedia, you can't wait seconds. You're expecting milliseconds. So over there, obviously, there's going to be a differently sized cluster to handle a lot of very fast searches. Where in the security world, we can probably afford to wait a second or two rather than spending a ton of money on a bunch of hardware to make sure we have 0.01 millisecond responses. It's not realistic. That's why it's always a balance between speed and scale. And why is that? Why does there have to be a balance? And this goes back to how searching works. So obviously, when you search, you are searching the shard, right? If you remember back here, if we go to the previous slide, you're searching through a shard, and an active shard is using up some of those Java heap resources. Okay, so it's there's a performance hit. The more shards you have, the more Java heap you need. So the bigger your cluster has to be able to afford to have so many different concurrent search threads. This is where the balance comes in, because if you don't need to have extremely fast millisecond search, then you don't need an index spanning 50 shards to get that super fast search. You can consolidate that into less shards, and you wait a few seconds instead of 1 or 2 milliseconds. That is where the trade-off has to happen. If you tell me, for example, that no, I have certain data which has to come back in 1 millisecond, regardless of my situation, regardless of how many different users are accessing it, then yes, you're going to want a different sharding strategy, as we say, to your data that doesn't need to be searched so fast. So for example, if you have data that you're going to search every once in a while, that doesn't need to come back very quickly, you're going to have a different sharding strategy. If your data isn't huge, you can probably get away with a single shard. And we always say, I'm going to bring this up in a bit, but a shard should be between about 10 and 50 gigabytes. More than that, then you're going to want multiple shards. So that is where the balance comes in. Speed versus cost. If you have unlimited budget for hardware, you have all the hardware in the world, then okay, then you can have a massive cluster and you can get searches back extremely fast, and for all your data sources, keep everything in hot, have everything on NVMe drives. So that is where I say balance. Okay, very important. And these are the things to keep in mind, right? So a search is running on a single thread per shard. The more shards you have, if you don't have enough nodes that can handle it, and then obviously they're going to bumble up into a queue, and if that queue gets full, and then things are going to wait, and things are actually going to take longer to run. So you have to be careful there. Shards have that overhead, so that Java memory, right? So make sure that when you choose a sharding strategy, you don't have what we call shard explosion, because as tempting as it may be to say, no, you know what, I'm going to have 10 shards per index across my 10 node cluster with a replica each. That's now 20 shards per index. And if you're indexing a lot of data, that's going to be expensive. So remember that shards have overhead. Obviously, the shards are balanced by Elasticsearch for the data tier. So if you have data nodes, Elastic will take care of making sure that your nodes aren't struggling between them. So to make sure everything is balanced. And this is why we say, if you have data tiers, the nodes need to be identical, because otherwise it's going to have trouble balancing. If you have one node which has a terabyte of storage versus another node that has 300 gigs, there's no way it can balance those properly. So that's why they need to have the same profiles. You're going to hear this come up. So if you've been using Elasticsearch for a long time, this might be a relatively newer term, which is data streams and lifecycle policy. So data streams are essentially the future, right? The data stream takes care of the end-to-end process of index lifecycle with rollover. It makes sure that there's the right alias. It gets rid of a lot of problems with index templates. In fact, Elastic Agents uses data streams by default. It is a much more streamlined way to handle data across a cluster. And again, it takes care of a lot of problems we traditionally have with indices. So we can send out a link specifically for data streams. I can't get into too much detail just because of the time. We're already up. We have 20 minutes left. So if you want more detail about data streams, we can send that over. But it's really important to start looking into them if you haven't. Data streams are the way to go going forward. And like we said, aim for about 10 to 50 gigs per shard. All right. I don't know why I left my presentation there. Now, for me, I always encourage users to think about the next step, which is cross-cluster search. There may be, I would say actually 95% of the time, if you're dealing with massive data sets, it doesn't make sense to keep everything in one cluster, because the overhead to manage that single cluster the amount of work Elasticsearch has to do in the background to make sure everything is maintained, it's going to get very overwhelming very quickly. For those of you who aren't aware, we have something called cross-cluster search, which essentially allows you to have multiple different clusters and be able to search them, search across all of them if you wanted to, transparently to your security analyst. And I'm going to show you what that looks like. But cross-cluster search allows you to take this sort of strategy instead. So instead of having to worry about, okay, I have my indices for my Windows events, which are growing at a rate of a couple of shards per week. Then I have my firewall logs, which are super noisy. Then I have my application logs. You can now put all of those into individual smaller clusters rather than having one massive cluster. And to the end user, it is transparent. When it's set up, and I'll show you what it looks like to set this up, it is completely transparent. Every feature except event query language, as of right now, we are working on that, but every feature except EQL works with cross-cluster search. So this is, the security app, dashboards, visualizations, data transforms, everything works with cross-cluster search. And this is key. So when you're doing that initial stage of planning and preparation, if you're going to see that you're going to have a lot of data very quickly, you're going to want to think about having separate clusters, either for different use cases, or if you're someone like a managed service provider, a different cluster per customer, or any way you want, really. There isn't really a restriction into how you set these up. This is your choice. It's also very popular for teams which are distributed globally. So if you have teams in the US versus the UK versus Singapore, instead of having to transfer data everywhere, you can have clusters in each region and then just search them centrally, because the data lives in those remote clusters. And when you search them, the expensive Elasticsearch operations happen on those remote clusters. So if I run an aggregation to calculate how many failed login events I had on Windows, it happens on this cluster, not on the others. So it's really important that the remote operations happen on those remote clusters. Let me show you what this looks like. So I have a cluster here. Great, I'll log in. I built 4 clusters for this demo. So I have 3 clusters with different data sets. I should say 2 clusters with data, and then I have 1 cluster searching both of them. So this Kibana instance that I am on now has no data in it. The entire Elasticsearch cluster doesn't really have any data at all, but I am connected to these 2 remote clusters, which have different data sets. I also have another cluster for monitoring. So if you've used Elasticsearch before, you've always heard us say, have a dedicated monitoring cluster. Why? Because monitoring data is more shards. You don't need to use production resources to search and calculate monitoring data. So that's why we always recommend having a dedicated monitoring cluster to take the cost of monitoring away from your production cluster. Very important, because monitoring shards they can grow very quickly as well. So just to keep that in mind, that's why we recommend that. So you can see I have my 4 clusters here, and this one is just for monitoring, and these 3 clusters are all reporting into this one in terms of monitoring. But what does it look like to search? So if I go into Elastic Security, so first of all, actually, let me do this so you can see that I don't actually have any data on this cluster. So if I go into monitoring, this is the first cluster I was on. You can see that that 9.5 megabytes of data, it's mainly just system indices. It's not like the others that have more data in them. But essentially, it doesn't have anything on it other than searching those remote clusters. So I'll just show you that in a second. If we look at those indices there, you can see that, actually I did send some data to it. But you can see not all of the data is on it. So some of the others have, if I take off the filtering, this just has packet beat data on it, for example. So, so sizing meetup 3, actually I just clicked on the wrong one. I do apologize. Go back. So my sizing meetup 1 is the one that has no data on it. This one does have data. While that's loading, I'll show you what the experience looks like for the analyst. So this is my, let's say, cross-cluster, my cross-cluster instance, right? If I go to the security app and I go to overview, I have data from my remote clusters. So you can see here endpoint security, packet beat, audit beat. This is all happening on remote clusters. And if you look at my data sources, this is what tells the cluster to do that. So when you're searching remote clusters, you can see you have your index patterns, but in front of it you have the cluster name. So because I'm searching across two different clusters, I just did cluster star. So any remote cluster essentially that I've named, and then I'm looking at my win log beat. I am looking at no local data because I don't have any. And the experience is just the same. If I go to hosts, I have the data from my remote clusters. I can use it and interact with it in the exact same way. The same for detections. So I can run detections based off of remote clusters. Like I did here, I set up one detection in this case, but you can see if I look into it, it's looking at my remote endpoint logs. It's not looking at my local ones because I don't have any. So this is also a key thing to implement for success. Don't try and have a massive cluster. You're just going to have it's going to be a much harder time. Have smaller clusters, either for different use cases or different teams or different data sets. Don't try and put everything in one, unless you really want to. That's your choice. But I'm always a bigger fan of having smaller clusters depending on what you need to do. So that's key. Cross-cluster search is available again everywhere in terms of whether it's in Elastic Cloud, whether you're using Docker, Kubernetes, whatever you want. You can run it again in any environment. It is a free feature. It is not a paid feature. Cross-cluster search, unlike replication is a paid feature, but cross-cluster search, anyone can go and use it without any restrictions. So do take that into consideration. Yeah, this is my cross-cluster search instance, and you can see the only indices I have are system indices. I don't have any data indices at all. All right. So I did want to highlight that. A couple of more things because we are running out of time pretty quickly. So CCS, very important. I'll talk about transforms at the end, but because I want to make sure we cover the detection engine. So for security in particular, because we have so many detection use cases, I mean, this is valid for any use case which is heavy on alerting, but because in security, we have a high expectation on detections, it's important to note how these run. So the detection scheduling, so what is dictating when what detection rule runs, is actually happening out of Kibana. All the state and the metrics for that are stored still in Elasticsearch indices, but the actual scheduling happens out of Kibana. So if you are running a heavy detection use case, there are a couple of things to consider. First of all, have more than one Kibana for resiliency, because if your Kibana goes down, you're not going to run detections. Plain and simple, you need to have more than one Kibana. And monitor as well. So once you start adding detections, you can see here in the detections view, we monitor the query time. So how long these detections are taking to run, if there's any gap, and it's going to let you know if your detections are taking long to run. Even per detection, if we notice that they're struggling, we will tell you. So when the detection will say, hey, this is failing, you're going to want to probably bump up your Kibana instances. Kibana, if you have multiple Kibana instances, that's taking the scheduling between them it happens transparently. It's really nicely well done. And you can scale Kibana either vertically or horizontally. So you can have multiple Kibana instances. You can have more what we call task manager workers per Kibana. So if you want to scale that way, you can. That is a setting within the Kibana YAML file. And this is sort of the how an alert actually runs, just in case you weren't aware. So you have the alert, which is being scheduled by Kibana. It's going to run the query on Elasticsearch. If you have results, it's going to take the action accordingly. If you're using an external integration, it will do that, and then it will report back. So there's a nice blog we have about the life cycle of an alert. But essentially, it's really important that your Kibana nodes are given good attention when you're doing detections. Typically, Kibana doesn't need anywhere near the amount of resources Elasticsearch needs. So even in our cloud instances, for example, the maximum you can have for Kibana is 8 gigs of memory for the node instance. So that's typically going to handle thousands of detections as we've seen so far. We are going to publish more detail about how you should be measuring your Kibana instances for detections. We haven't done that just yet. But based on what we've seen so far, I'm running 2 Kibana nodes in my cluster with 500 detections, and they are working well. But the monitoring page is going to set you up for success here. So make sure that as you're adding detections, you keep track of your monitoring, making sure that this isn't going crazy. It's a very important step if you're running a very heavy detection use case. I'm going to go over our last few things, and I'll take the questions that are in the chat. There are a few examples here, and since these are going to get sent, these are going to be made available to you. We probably won't go up to all of them, but these are some examples of what it looks like when you've done your preparation, when you found out how much data you're going to have. This is what it looks like to calculate how many nodes you need, what your total storage is going to be. And here's some examples. One is for a typically small cluster. One is for a slightly bigger cluster with 100 gigs per day. These are actually all on blog posts as well, but do go through these if you haven't. They provide quite a bit of good insight once you do have that first step of preparation. Without the preparation, you're not going to get very far because you do need that. You need to know how much data your data sources are sending and what that looks like in your environments. So the last thing I want to talk about, because we do have time and then we'll have a couple of minutes for questions, is data transforms. Again, this is a free feature, so it's not a paid thing. Transforms are my favorite, one of my favorite things in the cluster. And what is a transform? So essentially, a data transform, if you haven't used them yet, if you haven't seen them, it basically allows you to have continuous aggregations running on an index or a data set, and you write those aggregated result in another lightweight index. It's a similar concept to rollups. If you do metrics, you're doing rollups. Data transforms allows you to do anything you want with the data. It's really powerful stuff. So you can see here, one of the examples I have is things like having a data transform to calculate things like port scanning. So typically to detect a port scan, what you'll do is you run a very heavy aggregation to detect the cardinality or the unique count of ports that a source IP is running against the destination. And if you try and run that across a lot of data, that's going to be an expensive search to run, especially if you're dealing with terabytes of data per day. If you're on a transform, that's going to do that continuously. Okay, and I'll show you what I mean by continuously. So you can see here. And you can see it's churning through a lot of documents, and then it's indexing those documents. But when I go and do my search, I am searching that pre-aggregated data. So if I have a group of 10 analysts, for example, who want to run a similar search, instead of running 10 aggregations at the same time, that aggregation is done. I am searching pre-aggregated data. So to show you what this looks like inside of a cluster, let's go ahead here. So first I'll show you the transform. So there is a UI for transforms. There's an API as well, depending on how you want to set up these transforms. But to show you that example here, it's this one. So this is what I mean by that. So you see this is looking at my packet beat data, and it's running an aggregation on it continuously to look for potential port scans, and it's writing those results to an index. When I want to search it or when I want to write a detection on it, instead of doing that aggregation at search time every time, that aggregation is done. So if I go back to Discover over here, and we'll look at the scan ports test, instead of looking now and doing the aggregation at search time, the aggregation is done, and I'm going to look at the results. So I got 13,000 hits in a few seconds. All my data is pre-aggregated. That's it. So now I have a new index created, which is extremely lightweight, rather than having to do that aggregation at search time. So if you're going to be doing a lot of work, you have a ton of custom dashboards, your analysts are doing a lot of heavy work with aggregations, you're going to want to consider transforms. They're going to be really, really helpful, trust me, because you end up with even a lot less documents, a lot less data, a lot less heap usage. They are super powerful. Plus, you can do some really complex things with them. So, for example, I have a transform here, which is working out things like impossible travel. And we'll look at that for the last year. So impossible travel, I'm doing a lot of calculations on search times and speed and how fast someone was traveling between logins. I did this with transforms, and then I get my results written to an index. Boom. super quick. I didn't have to do this expensive aggregation at search time. It's already done for me, and then I get the results shown to me. So transforms are very, very valuable to have in this case. I'm going to move on to questions now, but just to wrap it up really quick, I appreciate we covered a lot of examples, but it's really important. If you had to take anything away from today, the preparation part is absolutely key. Make sure you are calculating and checking how much data you're receiving, so you can plan accordingly. You can have a good sharding strategy. You can size accordingly, and that is going to be the key thing to take into consideration. I'm going to move on to questions now, just because we have about 5 minutes. So let's go ahead and do that. So the first question was, how about multi-nodes on the same host machine? I am planning to deploy multiple ES instances on the same node. The nodes can have dual CPUs. The answer is yes, you can do that, whether you wanted to have a container strategy to do that, whether you wanted to have different virtual machines. So there are things to consider when you take that strategy, but you can do that. There isn't really anything stopping you. That's how we run Elastic Cloud. Everything we run in Elastic Cloud is Dockerized, as an example. So we have multiple containers, hundreds of thousands of containers running on bigger infrastructure. So yes, you can do that. It's actually encouraged. If you are in a situation where you can do that, absolutely. If you are into Kubernetes, same thing. So Kubernetes, we'll have a Kubernetes operator to help you do that as well. Obviously, Kubernetes is fantastic if you are into that world. And that's going to streamline a lot of this stuff as well in terms of scaling. So I do encourage you, if you are heavy into Kubernetes, to check out our operator. Cross-cluster search works in the same way, so on and so forth. So there aren't really limitations in that part. How can you prepare for a DDoS attack? There's a couple of different ways you can do it. That's where you leave a buffer. But if you're going to have a DDoS attack, like, you have to cater for some extra hardware buffer. But you also have to make sure that you have some safeguards in place that you can alert if that data is growing. So you can set up cluster alerts if, for example, your data is growing too fast. So one of the features that we have is you can see how many logs you're having in per data source. If all of a sudden your firewall logs from 1,000 events per second are at 100,000 events per second, you're going to want an alert for that, just so you can tell quickly and then remediate your DDoS attack. But obviously, you leave some buffer for things like DDoS for sure. So there were some couple of questions around authentication with CCS. So a very similar way, so you can have the same RBAC models. So you can grant permission to search remote clusters to your users and to your roles. That can all be defined in the role structure. So you can set that up. With CCS as well, you can do things like if a cluster happens to be down, you can say to skip it rather than having the search fail. But for authentication, it uses the same sort of RBAC model for your users. So you basically say this user is allowed to search remote clusters, and then it can search the remote clusters. So yes, so there were the question about bare metal, no containers or gates. Yes, you can do that if you wanted to. The most common choice for bare metal, you're probably still going to have some sort of virtualized architecture in front of it, on top of it, I should say. But you can, or run multiple ES instances on different ports. You can do that if you wanted to. Let's see. So there was a question about, I was exploring Xstack, but when I ingest nodes and see indices status was yellow. Good question. So yellow means the cluster doesn't have anywhere to put that replica shard. So if you're doing a replica and Elasticsearch doesn't have a different node to put it on, so because they should never live on the same, the primary and replica should never live on the same node for redundancy's sake, then it's going to mark it as yellow. It says, I have nowhere to put this shard. So obviously in production, you don't want yellow because that means you have data which is replicated, which cannot live anywhere. So, but if you're testing, especially if you're testing on a single node, you're going to see yellow indices. For testing, it is okay to have yellow. That's fine. But that's what it means. It means the replica doesn't have anywhere a different node to sit on, essentially. There was another question you did not tell us about how and where we can create rules and alerts. I'll show you really quickly. just because we are at the top of the hour. But you are absolutely right. I didn't show you. But there's a couple of different places. So within a stack, you can set up an alert if you go to stack management and alerts and actions. So you can set alerts on your monitoring data. You can also set alerts on individual data sets if you wanted to. And one of those we have is log rate. So if I create an alert here, one of the things you can do is log threshold. So you can do that. And then you can say, hey, if my log threshold exceeds a certain value for a certain data set, I want to know about it. So you can do that there. And the last question I'll take is, can Rally be used to test max indexing rate too? Yes, absolutely. Indexing rate and throughput. So very good question. The answer is yes. All right, we are at the top of the hour. Again, thank you all for joining. I appreciate there's a lot of content we went through, but we'll make everything available after this. It's going to be, it was streamed live, but it's recorded. Hopefully it's a bit clearer now about how you can size for security and any heavy logging use case. Do enjoy the rest of your day. If you're going out to celebrate St. Patrick's, have
Thank you
fun.
so much, James. Thanks a lot.
Thanks, Dalia, for having me. All right.
Of course. Have a great evening, day, whatever, everyone. Bye.